Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects, titled An Improved CH Selection Approach in WSN to Improve Network Lifetime. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the recent research that we conducted in the domain of communication networks, where sensors-based communication is being done. So before moving to the video, let's talk about that what we will cover into this video. In this video, initially we will discuss about where this sensor-based communication has been applied in the real-world scenarios. Along with that, whatever the code we have designed, how to execute it, which file is to be run, and what are the software requirements to run those files. Then we will discuss about what is the current systems, those are working in the same domain and a problem identified from those, and in order to handle those problems, what is the proposed methodology developed in this system. Then finally, we will give an overview to the experimental outcomes and the findings. So let's talk about the application areas. The IoT-based systems or the sensor-based networks are very much very much popular and are currently useful in many of the areas. One of the domain is like healthcare, where the remote surveillance of the patient is being done by using the sensors. Second application area where it can be implemented is for the smart agriculture, where the areas where the human reach is not effective, there the sensors can be deployed in order to monitor the agriculture like temperature, water, UV, and other related sensors based surveillance can be done. For the smart home, this is the third application area where this sensor based communication can be done and a smart home system can be developed for the surveillance, for the security purposes, where the drones or other related devices can be connected through the internet and can be remotely accessed. All these areas are very much effective and are very much popular these days and under research. The research challenge is basically the sensors that we are deploying in these application areas are restricted with the batteries, because no big batteries can be applied to them. One of the example you can see, like wearing the wearable healthcare watch, they are having a small battery in that and having very less power resources. So in order to save their energy and sending the data effectively to the base station or the remote location where easily the further procedure can be done, uh, it is a challenge to reduce the energy consumption and sending the data effectively. Inspired from this, we have developed this system, and it is applicable in many of the domains like computer science, where the routing protocols, communication protocols can be explored for the doctorate level or the industrial level application, where real-time applications are being working using the Android and other sensor-based work can be done in order to save the energy, because it is totally not only dependent on the hardware, it also depend upon the software and the protocol that is transferring the data. So now let's talk that what exactly the code is and how to execute it. So we do have the code like this. In this folder we do have the code. You just have the code files with you. In this code is implemented in the MATLAB software. So the MATLAB version that we are using is MATLAB 2019 A. You can use 2018 or above, but make sure the MATLAB software that you are using must be the full version or the trial version. So in order to run the code, you just need to go to the folder where the code is placed and you just need to copy it. You can just right click on it, copy, and then go to the MATLAB, and here you can see it is the same path file, and here you need to paste it and press enter. When you press enter, you can see all the files those were there in the folder are seen here in the current folder. You just need to open the main code. So when you will click on the main code, it will get open to the editor window where there is a run command. You just need to click on the run and it will start executing. In the meantime it is running, let's talk about the problem. Currently, many of the research has been done in the domain of sensor network. This is one of the article that we were following into it. What they have done, they have developed the sensor based network in which bee colony, artificial bee colony algorithm is being implemented along with three parameters for the cluster head selection. But the challenge that we have given into this scenario is like the clustered selection parameters are effective. The three of the parameter that they have taken is the remaining energy, node, degree, that is the connecting nodes, along with the distance from the sink. These three parameters are effective, but the algorithm artificial bee colony is not that much effective because it is less capable in exploring the new solution. It is restricted to be in the local optima. Second problem that we identified is that in most of the scenarios for the sensor networks, when nodes are evaluated, the systems node are randomly deployed in the network, which can affect the uniformity of the network's sensing areas. So in order to handle that, one of the advancement that we have done in the proposed methodology is to deploy the nodes in a uniform manner. For that, we just split the network into the grids in which the total number of nodes are divided equally as per the count of the grids. Here you can see 9 of the grids have been deployed, and in every grid there are around 10 nodes, which is the uniformity deployment of the nodes. One of the advancement is this. In the second scenario, we have replaced the artificial bee colony algorithm with the gray wolf optimization. So gray wolf optimization, artificial bee colony optimization, artificial bee colony algorithm, it was proposed in earlier of 2005 around, but later on many of the algorithms has been proposed. So inspired from that, we have used the gray wolf optimization algorithm, which is proposed in 2014, which is the recent one with respect to the artificial bee colony, except that it has the properties of more exploration, not get stuck in the local optima, fast seeking speed. So these effective advantages of the algorithm inspired us to implement this in our proposed method. So after implementing the whole scenario, here you can see when we run the file, all the configuration has been taken from the base paper. Initially we are calculating the parameters those are required, like sink to node distance, residual energy, node degree, all these factors has been calculated. Later, by applying the proposed GWO method, we are selecting the best cluster heads, and then communication has been done as per the standard scenarios. And finally, a comparison has been conducted with the base paper. So we have considered this paper, you can consider any other paper also in order to defend the effectiveness of the proposed system. So the factors they have considered, let's talk about the results now. Alive nodes, dead nodes, then residual energy and the throughput are the four parameters that they were considering. So the algorithms are Leach, PSO, SA, PSO, and PBC-CP. PBC-CP is their on algorithm that they have proposed in the paper. So what we have done the comparison in the same scenario. After implementing the network, we just compared our results in terms of the alive nodes. So the black curve is of our proposed work. So you can see even after 2500 rounds which were in the base paper, our system is more stable and not yet all the nodes dead. Similarly, the dead nodes, which is the reciprocal of the alive node graph, has been shown. So you can see still network is stable, all the nodes are not dead so far after the 3000 rounds. Then this is the throughput calculation with respect to the rounds. And finally, we do have the remaining energy of the network. You can see the initial depletion is larger, but still it is stable up to 3000 rounds. So it means our system is more stable and more effective in comparison to the existing methodologies, and further modifications are still possible. The uniform deployment and the clustered selection approach has been improving the battery consumption of the network and making it stable for the longer period. So I hope you people like this video. For the further application development for the real-time IoT based networks for the industrial as well as for research purposes, you can contact us directly. Thank you. Thanks.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, We offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.